Hi. In case you didn't follow me during the lecture last week, this week, so I hope this video can help you understand more clearly about the coordinates relation between the SolidWorks and the RoboGuide. Okay, so let's start. Okay, so in the SolidWorks, let's open a file I designed uh, for you to understand the orientation relation. Okay, so for this part, I have labeled the surfaces with the according to the XY direction in the SolidWorks, right? So you see the tri-eyes here. So X, Y, and Z, and the surface labeled is kind of a normal to this axis, right? So X, Y, Z, okay. And also the origin of this part is on top of the surface, and exactly in the middle, okay. So yeah, let's remember this orientation, and you will see later after I save it as the part, save it as the IGS part. Let me overwrite the part I of this one, right? So okay, so XYZ model, okay. Later, after I import it into this RoboGuide, you will see, okay, that direction is just will kind of bind with uh, the orientation inside of where it's is linked with is bind. Okay, so for this part, let's see first. Let's assume it's a part designed for the UT end of two. Usually end of two, I mentioned that in the class is for uh you know the for example if it's a jaw, so you may mount it in the base. The jaw part is moving, but you have a base part, right? So that part you don't really move it, right? So it doesn't really have a motion. So that's just a part connect with the final axis. This not final joint. This one is G6 of this robot, right? So okay, so let's see. When I highlight the UT, click the UT on the tooling tree here, you will highlight the location. I mean, not location. The original location of the this UT. UT represents end of arm two. Okay, it's the end of this tool. Okay, so now you see this one, this green coordinate, the triads. That's for the original location of this UT. So you can also see the detail information by choose the UT properties. Then in the general tab of this UT, you will see, okay, the location of this UT is here, XYZ. So now Z you have a 10 millimeter because I moved it just now. So if you don't do anything, so original it should be 000. So all the zero. So you see, then this part, this location will be kind of on the just on the surface of this J6 joint 6. Okay, so now that's empty on the joint 6. So okay, if we want to import a base, right, to this location, connect with this joint, this flange. So we will go here, cat file. Okay, so point to the direction. Let's use that model designed in the SolidWorks, which is this one. Still remember this XYZ. Okay, so let's see. Let's go back to okay. So for the UT, this location we want that part to link with. You have this X here, Y here, and Z here. When we link it to the SolidWorks part, you will see okay, all these axes or orientation will be matched. You know, to each other. So I have clarified the link, but you need to apply here. Okay, here. So now you see X, Y, and Z. So this one is just linked to the like a yeah. But I can click this new linked part. Now this linked part is also UT. But before I link this CAD here, there's empty. It's empty. Now, when I click this part, this base, so then you can highlight that triad of this location. So you can see you have x normal to the x surface, y normal to the y surface, and z normal to the z surface. You can see the coordinates inside of SolidWorks match with these coordinates of this joint 6, this location, this or UT end of the ARM2 location. Okay, so and you can, for example, if you want to change the the location, give it some offset or some angle, so you have two methods to do that. First thing is, for example, drag manually, right? Drag S, Y, Z, or rotate it, okay, right, like that. So, or you may have already noticed that. See here, notice that, you see, X has been changed, right? So you can change it back, 0, okay, it will move back. So you can also use this change these values here to either drag it, or change the number here. Okay, that's how you this is kind of the relation between the SolidWorks file and this location inside of a RoboGuide. Oh, this is the first thing. Okay, so then in our homework or the simulation, you also will import something like JAWS, right? Which in this RoboGuide, they will be treated as a link, under this EOT. So that's why sometimes I don't want to use a link as a term for the kind of point to the CAD file, because I don't want you to understand it with this link concept term inside of this EOT options here. But let's see, if we want to add a moving part to this tool, so we will choose add link, then select the CAD file we want to use, right? So again, I will use this XYZ model because it has this label on the surface to demonstrate that. So okay, when I click it, open, now you can see there is a link under the EOT, you see on the on the left, on the tooling tree here, you have a link under the EOT1. Okay, so then for the pop-up window here, you have this link once options, right? Instead of EOT. When I click EOT, so it will change back to the EOT menu. Okay, so you can see, okay, they are different. So then for the link, which is a moving part usually, let me rename it as draw. Yeah, just name it as draw, right? So then, okay, so you can see under the link tab here, so you have a different, like a specific location you need to point, right? So based on the draw you want to use. And then you have its own location, y, right? So it's all 0, 0. Now, but we cannot see that that draw, right? Why? Because it's overlapped with this, because we use the same model, so it's overlapped with the UT like a CAD file. So let me change the location of this link, the draw, right? So 100, boom, it out. Okay, so now you can see, okay, for these two things, the coordinates, what are the different? So when you click the EOT, so it's the origin is here, right? So on the surface of this joint 6, and then when we click this draw, this link, so it has its home coordinates over here. Okay, so this is how you set up this coordinates. Again, I mentioned before, so yeah, most of the parts, of the inside of this or components inside of this RoboGuide has its own coordinates. Like when I click the base of this robot, you have the coordinates orientation Z towards the top, and you can drag it to different place, right? So you can also menu this the other location over here, right, to change it to different position. Sometimes I want to let you know. I want to emphasize that, for example, for this draw part, the location here you have this XYZ, and also in the general you have this XYZ uh, of this like XYZ WR PR. That's not for the location of the draw, so it's for the location of the servo motor or the force to drive this, that location. So that's different. So don't mix them together. Okay, so I would just yeah de-highlight it, and again, like this linked draw, you want to go to links CAD, the CAD file, then the location, change location here, and for the UT, it's in the general tab, so change the location here, and for for example, like this base, you can change the location over here, or if it's a part, remember you I mean import a machine, a part, a pallet, so they all have its own coordinates. Okay, so that's something I want to emphasize. Then lastly, let's I mentioned how to change coordinates inside of SolidWorks during the class. Quickly, let's go through that. Let me open another file because this file is an IGS file. I cannot really edit it. So let me open SolidWorks, or let me just make a new one. Let's make a new part. Okay, so here, okay, let's draw a new part here. Okay, just draw a kind of like a block and extrude it to something like this. Okay, so all right, so for this part, if I highlight the origin is here, right? So clearly if you import it, so the origin will be kind of link or matched with that origin inside the RoboGuide. But now I want to change it somewhere else. For example, a surface here, if I want to change the coordinates or origin here and have different coordinates direction, so I can edit this surface, draw a reference point here. Okay, so then so then I will go to first select this point, then insert reference geometry, then select coordinate system. All right, so now you can see, okay, the pop up the menu on the left. So at the position here, so this is the point you to set up the new origin. Then, for example, if I want to change the orientation of this Z direction, which is a Y direction, is green, all right? So I just go to Y on the left, highlight this one, then select the surface you want the Y normal to. See now the Y normal. Similarly, like for example, the Z direction, which is the blue one. If I want to change the orientation, I mean it towards. So I can change it to for example blue. I want to change it to here. You see the Y normal to the new surface now. Yeah, so that's how you change it. Then okay, so by clicking the green like a check mark, so then okay, you see the new coordinate system be set to here. All right, so then how to use it, right? So you need to save as IGS, and then in the option, go the bottom here. Instead of default, we choose that coordinate system. After click OK and save, this part will have this new this coordinate system here. So to make it more easy to see, I will actually use this point here. insert reference geometry. I will insert another one like this. You have this. Let's just keep the origin like let me see which is Z. Green, blue is Z. See like this, and put the X towards to X is red. Okay, towards here, and then Y towards to Y toward here. Okay, so let's use this orientation. So let's see what happens. Save as. Okay, so IGS. Okay, this one as YZ BBBB. Okay, then option go to. Okay, so you see we have multiple system here, which is two, which is the last one I said save. Okay, so later I will import. It will use this point as the origin. Let's see. Go back to place one. So I will use let's okay. Let's use U2 here. So I can use 3. So you can when I click U3, okay. So all the parts imported disappear. Why? Because here just for for clarify this I mean the purpose is multiple UT end of ARM2 because that's for example uh, the CNC machine in our in EDC actually can grab it automatically grab different type of drills, let's say, right? So it can automatically change different tools. So for in the simulation software here, why you have so many different U2 here is because I mean, there's for applications like they have multiple tools, right? It can automatically change from the settings here. So, but for us, we mainly only has one, right? So that's the thing. But again, so yeah, you can see that's the reason when you select different tool, you can set up for that tool, and you will not see the other setting. Okay, let's use this one. So to import the new part we just made, XYZ then apply, you will see, okay, you see it's using that new origin, the system two origin, like a coordinates system two, right? So that's how you change the origin coordinates inside of SolidWorks, right, to make it has a new coordinates over there. All right, so all these is for your reference. Hope you can understand more about how to use the RoboGuide with the model you designed the SolidWorks. Thank you.